All right, everyone. Let's go ahead and get started on this assignment. My apologies for not being here today or having this video up sort of late. Just wasn't able to get there. I'm not feeling so hot as I know some of you guys are feeling at the moment as well. All right, but this is our last assignment for this chapter, working on logarithmic word problems. Okay. All right, so this one goes use properties and the rules for logarithmic functions to solve each problem. Okay, so chemists define the acidity or alkalinity excuse me, of a substance according to this formula. Okay, formula is going to be the pH of a substance is equal to negative log of H plus, where H plus is the hydrogen ion concentrate measured in moles per liter. And solutions with a pH value of less than 7 are acidic, and solutions with a pH value of greater than 7 are basic. Okay, solutions with a pH of 7, such as water, pure water, are neutral. So this is kind of like, for those of you guys are chemists, people, and you probably can relate to this. Suppose you test apple juice and find the hydrogen ion concentrate is H plus equals 0.0003, right? So we know the H plus is 0.0003. We want to find the pH value and determine if the juice is basic or acidic. All right, so that's going to go something like this. All right, so we're going to go ahead and use our formula they gave us, which is pH equals negative log. Okay, but instead of H plus, we know that H plus is 0.003, so we're going to go ahead and use 0.0003. Okay, and this right here in our calculator is just a basic log, so we're going to go log and then just negative and then hit the log, and that's log base 10, 0.0003. That's all you got to do, guys, gals. So we get 3.52287 and a bunch of other numbers, right? So our pH comes out to be 3.522, right? And basically, if it's less than 7, right? So if a pH value of less than 7, it's going to be an acidic solution. So apple juice is going to be acidic. Okay, that's it. That's all you got to do. Okay, next one. If you test some ammonia and determine the hydrogen ion concentrate to be H plus equals 1.3 times 10 to the negative 9. Okay, find the pH value and determine whether the ammonia is basic or acidic. Okay, now some of you guys may be a little freaked out by this, but this is just a very small number. Okay, 1.3 times 10 to the negative 9, that looks like this. Okay, it's 1.3, and the times 10 to the negative 9 means we're going to take this decimal place and we're going to move it 9 times to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's where the decimal is going to go. So now your number is actually 0.0000000, one more zero. Okay, so 1.9 times 10, 1.3 times 10 to the negative 9 is actually this number here. And then remember, the decimal has moved, so it'll be a 1.3 at the end. Okay. And what I want to do is I want to find out what the pH is. So it's going to be pH equals negative log of this amount. So in my calculator, I'm going negative log and then that number, which is 0.123456781 Okay, let me double check that. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 3. All right, and that comes out to be 8.886. Right, so and then if you're looking there, a pH value of greater than 7 are called basic. So this one is a basic. All right. Part C. You squeeze some tangerines into a test tube and test that the pH level of the juice is 8.5. What is the hydrogen ion concentrate of the tangerine juice? All right, so this one's a little different. Okay. This one doesn't say that H plus, right? It doesn't say that H plus is that. It doesn't say that the hydrogen ion concentrate is 8.5. This one actually says that the pH is 8.5. So instead of pH, right, we're going to write down 8.5 because that's what it is. So the pH is actually 8.5. And that's going to equal negative log of that H plus. So what we need to do is we need to figure out what the H plus is, or the hydrogen ion concentrate, right? And this is going to be using some of the strategies that we've learned. So first, I'm going to go ahead and take or you could say divide both sides by -1, right? That's going to give me negative 8.5 equals log of H plus. Excuse me. And to get rid of that log, remember this log is a log base 10. So to get rid of a log base 10, we are going to go ahead and exponentiate base 10 both sides. And that's going to take this out. That's going to give us our H plus. It's going to equal, but we need to figure out what H plus is, and that's 10 to the power of negative 8.5. Okay, so the hydrogen ion concentrate is, you ready for this? This number over here, it's going to be 0.1234567 and then 31622. So I'm going to actually move this over. So I'm going to go ahead and do 316. Okay, that's what your H plus is. Or you could put 3.16 times 10 to the negative 9 if that's how you like it as well. Okay, that's the first one. Hopefully, most of you guys saw this or was able to do this, even if I wasn't in class today. The way I set this up is the first two, A and B, is usually just plug it in and just figure something out about it. And then part C is actually you're going to solve it. So, okay, number 2, the loudness or decibel, or which is measured in decibels, is the formula. The formula for the loudness of a sound is given by dB, which stands for decibel, which is equal to 10 times log of I, which is the intensity, over IO, which is the threshold intensity. Okay. The threshold intensity is the sound that you can barely perceive. So basically, if you're just talking very quietly and you can barely hear it, that's the threshold intensity. Right? So, and then all other sounds are based on how many times louder they are than the threshold intensity. So a cat's purr is 316 times as intense as the threshold intensity, or the threshold sound, or a cat's purr is, the intensity is 316 times louder than the threshold intensity. Okay. Okay. So for a decibel rating of, so we want to find the decibel of a cat's purr. So we'll go with dB equals 10 times log of the intensity of the cat's purr, which is 316 times the threshold. That's 316 times louder than the threshold intensity. And then notice how it has divided by threshold intensity. That's a way to kind of even things out. Okay, not because it is, but that's just how it works out. Okay, and you notice that IO, that extra um, threshold intensity, actually just cancels out anyway. So you're gonna put in your calculator 10 times log 316. Oops. Just like how I have it right there. And you're going to get 24.996. Okay. So a cat's purr has an intensity of almost 25. decibels. So when a cat's purring, yeah, that's about 25 decibels if you have a decibel or a sound meter. Okay, B. Considering that prolonged exposure to sound above 85 decibels can cause hearing damage or loss, and considering that a gunshot from a 22, that's a small caliber rifle, guys, but it will still do damage, so don't play around with guns, please. A gunshot from a 22 caliber rifle has an intensity of I equals 2.5 times 10 to the 13th power, as loud as the intensity, the threshold intensity. Okay. Should you follow the rules and wear ear protection when relaxing at the rifle range? Right. So we're going to do this again and do dB equals 10 times log, and then the intensity for a 22 gun rifle, saying it all weird, as 2.5 times 10 to the 13. And if you want to know what that looks like, 2.5, and you're going to move this 13 times to the right. This time, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's where your decimal goes. So that's the intensity of a 22 caliber rifle gun going off. This is this many times as intense as the threshold intensity. So that's pretty loud. Okay. Even though, yes, Mr. Shaw did say this is a pretty small caliber rifle. Okay. So that's how many million or billion is that? Let's see. That's 1,000 million billion 25 trillion 1,000 million billion trillion. I don't even know what this is. It's a big number. So it's that. So you can write that in. Okay, well that's what I'm gonna type in. But I'm gonna be a little lazy and I'll write 25 times 10 to the 13 power. Okay, that's 12 zeros. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. As intense as the threshold intensity. So that's gonna be IO and the IO also on the bottom, which is gonna eventually just cancel out. Okay, so I'm my calculator. I'm gonna type in 10 times log. And then you can type it either way. 25 with 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's it. Okay, or you can go 10 log, and then you can do how they have it, 2.5. And then that little EE button, where is it at? I've seen this. Oh, up right here in yellow. So you do EE. That means that times 10 to the, and then we can put in 13 power. And you see it's just going to come out to be the same thing. Okay, so this is going to come out to be 133.979. Okay, around 134. Okay, almost 134. So the suggestion is any sound, prolonged exposure to sounds above 85 decibels can cause hearing loss or damage. So if this is already 133, okay, you need to wear ear protection. So you need to follow the rules and wear ear protection. Right? So should you follow the rules? I would say yes. Wear ear protection. See how useful logs are in everyday life? Okay, last one, or at least for number two. Okay, letter C. You borrow a decibel meter from Mr. AV and find that a whisper to your friend registers at 20 decibel. Yeah, a whisper is still pretty loud. How many times more intense is your whisper than the threshold sound? So this one we want to do, we know that the decibel is actually 20 decibels. So instead of dB, we're going to start with 20. That's going to equal 10 times log of the intensity, which we're trying to find out, right, over the threshold intensity. So like that. Okay. So we'll leave it like that, and you'll see why all of these are written in terms of, right. So this first one per A, if you recall, it says 316 times as intense as a threshold sound. So that's why I wrote it as 316 times IO. And this one right here, 22 rifle has intensity of this much times IO, right? So it's all times the I sub O, which means as intense, that many times more intense than the threshold intensity. So we do actually need to leave it like this. And you'll see why in a second. Okay. So to solve this, I'm going to go ahead and use my solving strategies. Divided by 10, cancel these out. This will give me 2 equals log of the intensity over the threshold intensity, IO. Okay, and to solve this, remember this is log base 10, even though they don't write anything. And that's the reason, because we use log base 10 so much that we just choose not to write it. So we're going to go ahead and exponentiate 10 both sides. So that'll be 10 to the second power and 10 to the log base 10 of I over IO. Okay. And those are going to cancel, and that's going to leave me with 100, because that's what 10 squared is, equals the intensity over the threshold intensity. Right, and to solve for intensity, we're just going to multiply both sides by IO. So therefore, we get the intensity of your whisper to a friend is going to be 100 times the intensity of the threshold intensity. Okay, and notice that all of these were always in terms of that many times more intense than the threshold intensity. Okay, 316 times as intense as the threshold intensity. So they're always compared to the barely perceivable sound called the threshold intensity. All right, one more. This one's fun. A lot of reading, but fun. 19. Well, I'll let you read through all that wonderful stuff, right? Important thing is you have this right here. So you start with M equals log. And this actually looks very similar to what we just did. Except it's missing the 10. Okay. So the M, right, is the magnitude. So if you hear about earthquakes on, the radio or on the news, okay, it's always measured based on the magnitude, right? And the I is the intensity of the earthquake, and it's always based off of, how much times stronger is it than, the basic earthquake, which has an intensity of 0. Okay. All right. So say in the early 20th century, an earthquake in San Francisco measured 8.3 on the Richter scale. Okay. With what intensity? How many times more intense is the standard earthquake? Is this right? So 8.3. That's already the magnitude, and you'll hear, the earthquake that was in Mexico a couple years ago. That was only like a 7 point something. Okay, I'm just making this up, right? So when they say 7 point something, that's already a magnitude. That's measured on the Richter scale. So the M is actually, now we're going to use 8.3. So M is 8.3. And we're going to go ahead and solve for the intensity, right? How many times more intense is this than the standard earthquake? So again, this is base 10, even though is not written down. You just go ahead and exponentiate base 10 both sides. So base 10 of 8.3 equals base 10 of log base 10 of the intensity over the standard earthquake intensity. Okay, and these cancel, and you will have intensity over the standard earthquake intensity equals 10 to the 8.3 power, right? So in our calculator, we'll throw this out. So 10 to the power of 8.3, that's going to be a big number. Okay. So this is going to be 1,995,2,6,2,3,1.5. Okay, and then we're going to multiply both sides by IO, the standard intensity. So then that's going to just give me, here, I'll move this little equal, and IO here. Right, so the intensity of that San Francisco earthquake that measured 8.3 is actually 1,995,2,6,2,3,1.5 times stronger than the standard earthquake. And the standard earthquake is the earthquake that you can barely feel beneath your feet. Okay. Oh, and that's your solution. So that's about 199 million, so almost 200 million times stronger, okay, than your standard earthquake. All right, next one. In the same year, another earthquake was recorded in South America that was 4 times stronger in intensity. Okay, what is the magnitude of the earthquake? So 4 times stronger in intensity. Okay, so we're actually talking about this San Francisco earthquake, right? So in the same year, another earthquake was recorded in South America that was 4 times stronger in intensity. So 4 times stronger in intensity. So we're going to take that number right here, and we're going to multiply that. We're going to multiply that by 4. And they want to know, what is the magnitude, right? So 4 times stronger. So that number right there, I'm going to go times 4. So that's 798,104,926. Right? And they want to know the magnitude. So the magnitude is going to be, use M, right? So M equals log of the intensity, which is 798,104,926 times stronger than the threshold intensity over the IO. And just like how the last one was, these will cancel out, and you're just doing the log of that number. So I'm going to go ahead and use my answer. That gets me to be 8.9. So you can see that the magnitude of 8.9 versus the magnitude of, oops, let me put this back. The magnitude of 8.9 versus the magnitude of 8.3. Okay. If you think about it, from 8.3 to 8.9, that's not a lot. But in terms of intensity, how much times stronger? That's actually 4 times stronger. So magnitude is measured differently than intensity. So just something to think about. Okay, last one. The Valdivia earthquake, or Great Chilean earthquake, on May 22nd, 1960, is the most powerful earthquake ever recorded. Okay, I'm sure there were more powerful ones, but we were probably really primitive and we didn't have ways to record it. So various studies placed it at a 9.4 magnitude. How many times more intense is this earthquake in comparison to the standard earthquake? Bless you. Bless me. Okay, so we already know that the magnitude is already 9.4. Okay, so the magnitude, so I'll write this down. Magnitude, actually, I want to use green. Okay, so we already know magnitude is equal to log of the intensity of the earthquake over the standard intensity, meaning the earthquake that you can barely feel underneath your feet. Okay, so the magnitude of the Great Chilean earthquake is 9.4. So you're thinking, 9.4, that's only a little bit stronger than the 9 point, whatever our other answer was. Oop, I lost it, huh? Well, you got the answer. Oh, it was 8.9. Right, it was right here. Log of the answer. So this other answer should have been 8.902. So the magnitude was 8.902. Sorry. So the South American earthquake was actually 4 times stronger, but the magnitude was only a little bit strong. It seemed like it's only a little bit more than the San Francisco earthquake, right? 8.3 versus 8.9. Okay. But now, and we're thinking, hey, you know what? 8.9 to 9.4, that doesn't look like it's too far apart, but let's see how many times more intense. Okay. So that's going to be equal to log and the intensity over standard intensity. So again, this is already base 10. Okay, not showing it, but we already know that. So this is going to be 10 exponentiate both sides. 9.4 equals base 10 of log base 10 intensity over standard intensity. Okay, and as usual, this cancels out. So we get intensity over standard intensity. And that's 10 to the 9.4 power. Actually, I'm going to swap this around if you guys don't mind. So I'm going to put, so that's going to equal, so 10 to the 9.4. So in my calculator, go 10 to the 9.4 power. And that comes out to be 2.511886432, or 2,511,886,432 times. And then we just swap this out times by IO. That's how many times more intense is this earthquake than the standard earthquake. Okay. So the Great Chilean earthquake is 2 billion times stronger than the earthquake that you can barely feel underneath your feet. That's the intensity of it. And then on the Richter scale, we're giving it a rating of 9.4. And again, 9.4 doesn't seem like so much away from 8.9, but it's 2 billion times stronger, whereas 8.9 is only 798 million times stronger. Okay, so all right, that's a wrap, guys. Hopefully you enjoyed this session. I actually enjoyed this one very much. Okay,